Alright, hello everyone, this is Mr. Crozier, and I'm going to help you with the story problems from this packet that we've been doing in class. So I'm going to do problems 4, 5, and 6, and problem 8. Problem number 4 is about an arc length problem. It says a circle has a radius of 36. When they give you these problems, always draw a little sketch of the picture. And it says find the length of the arc. Well, when we're talking about lengths of arc, what we're talking about is this distance going to a certain point on the edge. And that's a length problem. That's a circumference problem. So circumference equals 2 pi r is the type of problem we're going for here. That's our circumference formula. So we just go ahead and plug in the numbers. Well, always get in the habit of drawing them out in a straight line and just plug everything in here. We have a 2, we have a pi, we have an r, well the radius is 36. However, we don't want all of it, we only want a part of it. So we take this, and when we switch to arc, we use the same formula, but we just put in 8 degrees over 360. Now if you wanted radians, there's a different radians formula you can use, but we have it in degrees, might as well just use it like this. So we're going to put in the arc that we want, and they said 135 degrees, so they want this much of the arc. Not all of it, part of it. So I just put in my 135 over 360. Now we have pi in here, so it's going to be a little messy. Let's do without pi first. 2 times 36 times 135 divided by 360. See what we get? Hey, we get exactly 27. So the exact answer is 27 with the pi, and the unit is in inches. So that is an exact answer. Now this problem does say to round. So now we could round and hit times pi, and it said 1 decimal, 84.8 inches is the distance. So again, always try to get the exact answer first, then see if you're supposed to round. Number 5, it says a clock is spinning around. The second hand of a clock is spinning around 9 centimeters long. What's the linear speed? Well, we're going to do all of this work and get to an answer of feet per hour. We're going to start with this angular speed and switch to this linear speed. Well, the angular speed of a clock, a second hand, is that it's going 1 revolution around in 60 seconds, right? That hand of the clock is going around 1 time in 60 seconds. So that's why we're in angles right here. Revolutions are angles, feet are linear. So we got to switch between these, and the switch is trigonometry. And here's the trig conversion factor I know. 1 revolution around the circle, we just did a revolution, 2 pi r. 2 pi, what's the radius? Radius is 9 centimeters in this case. So now we've switched from angles to linear. We switch from angles, which are revolutions. If I draw a revolution, it looks like that. If I draw a centimeter, it looks like that. We've switched from revolutions to linear distance. All right, now we just have to finish it. What can we say here? Seconds, 3,600 seconds is an hour. Good, good. Centimeters, 2.54 centimeters is, let's see here, 1 inch. And good, good. And an inch, 12 inches is a foot. All right. There's no directions for rounding here, so we got to be careful here. We have a pi in there. Let's keep that. Let's go ahead and do the math and just keep the pi out of this. Let's see, what do I have here? 2 times 9 times 3,600 times 60. Whoops, divide by 60. Divide by 2.54, divide by 12. So we have this number here. Well, let's take it to a fraction. And let's take it to an improper fraction. And there we go. 4,500,127 pi. That's an exact answer. If you want to check the math with an estimation, it's 113.325 feet per hour. So you can have that right there. But again, if it doesn't say to round, let's go for this one. There was no rounding in here, so let's try and stick with that one. Number 6, the circular blade of a saw. Again, it tells us what it's rotating. 3,006 revolutions per every minute. And we want to get to miles per hour. Let me write it this way. Let's write it like this. Miles per hour. Well, angle, angular speed, distance, linear speed. Well, the one trig conversion factor right here is the fact that one revolution, and we did it up here, 2 pi times the radius. Well, what's the radius? The radius here is 3 inches. And gone. Well, what can we do here? Let's take the 12 inches and turn them into feet by division. Let's take 5,280 feet, turn it into a mile. And let's take 60 minutes and turn them into hours. Good, and the math here is, again, we'll leave pi in here. Let's not deal with that because that's going to get us an estimation. Times 2 times 60. Divide by 12, divide by 5,280. Press enter. And we have I think I typed it in wrong. Let me go back over this. 3,600 times 2 times 3 times 60. Divide by 12. Divide by 5,280 feet. And that looks a lot better. Let's get a fraction to decimal or decimal to fraction. And change this this mixed number to an improper fraction. And there we have it. That is our answer. If you want an estimation, well, 225 with a pi divided by 11 is about 64.26 miles per hour. But again, there's our exact answer. All right, last problem is a sector problem, or a sector. So we have a sprinkler, and it's spraying out water, through an angle of 35 degrees. So the sprinkler is just set to go back and forth over this area. Well, area of a circle is pi r squared. So we have pi, radius, 25 squared. And if we only want a sector, again, we're going to shrink it down by multiplying it by degrees over 360. 35 degrees, 360. Don't need all this extra room right here. And again, pi, leave it there, 25 squared times 35. I'm just going to do this way. I'm going to do it this way. That's 21875 in the numerator, 360 in the denominator. Now let's simplify that fraction. 21875 fraction 360, and change it to from mixed to improper. And there we go. 437,572 with a pi, and doesn't say to round, so I'm going to leave it like that. But if you did, let's see here, what do we have? 190.895 feet squared. All right, what you can see on these problems is it's all about conversion factors, and draw a nice line, put them in one by one, and work your way across. Save the pi till you do the estimation. Most of them don't call for an estimation, only this first one did up here. And the other thing is when you're converting these, there's this one conversion factor in here, right here. This is the trig conversion that switches you from angles down here at the bottom, angles to distance, angles to distance, and that's the switch from there. All right, hope that helps with your story problems.